we are going to discuss about the RC transient. RC transient analysis. So, in last class itself we have discussed into the what is the difference between steady state analysis and transient state analysis, and also we have derived the transient response for RL series circuit. So, today we are going to discuss about the RC transient analysis. So, we are applying into the DC voltage V through switch. We are going to take the R and C, both the elements are connected into series manner. So, R and C. Now, we are going to close the switch S at t is equal to 0 second. Now, the current will be flows through this circuit is we are going to take I of t. So, applying KVL for this circuit, applying KVL. So, R into I as per the Ohm's law. So, I of t into R plus the capacitor voltage across the capacitor is 1 by C integral of I of t into dt is equal to applied voltage V. So, you can take this is for equation number 1. Now, what we are going to do means we are going to apply the Laplace transform on equation number 1, applying Laplace transform on equation number 1. So, we know the I of t is converted into I of s into R plus 1 divided by C. The integral will be converted into 1 by s. So, 1 by sc into I of s is equal to V by S. So, in these two terms we have a I of s is common, we can take down the outside. So, R plus 1 by sc is equal to V by S, V by S. So, we need the I of s. So, I of s is equal to V divided by S into R plus 1 by sc. We are taking into the LCM of this term means, so V divided by S into RC plus 1 divided by SC. So, the S will be cancelled, remaining is V divided by 1 plus RC divided by C. So, this is I of S. So, once again we are taking into the 1 plus S into RC. We are taking the RC is outside means, so I of S is equal to so V divided by C. So, we are taking into the RC is outside means S plus 1 by RC. Now, the CC will be cancelled. So, I of S is equal to V by R into S plus 1 by RC. So, you can take this is for equation number 2. So, our ultimate aim is we are going to find the I of t. So, I am going for that purpose I am going to take the inverse Laplace transform on equation number 2, inverse Laplace transform on equation number 2. So, I of s will be converted into I of t. So, V by R into 1 plus 1 by RC is e to the power minus 1 by RC into t. So, this is the transient response, transient current equation for RC series circuit. Now, we can draw the transient response for RC series circuit is. So, we know the first we are substituting into the t is equal to 0. First we are substituting into the t is equal to 0. So, I of 0 is equal to, so we are substituting the t will be 0 means e to the power 0 will be 1. So, we get the value is V by R. One more extent we are substituting in the t is equal to infinity means t will be infinity means e to the power minus infinity t will be 0. So, 0 into anything will be 0. So we can draw the response for RC series circuit means, so t I of t, so the time will be 0 means we get the V by R, the time will be infinity means we get the I of t will be 0. So this is the response of RC transient analysis. Next we are finding the time constant of RC circuit, RC transient circuit. So time constant T is nothing but of tau. So tau is equal to RC. For RC transient, the time constant tau is equal to RC. So we are substituting into the equation number 3, means I of t is equal to V by R into e to the power 1 by RC. So instead of t, we are substituting into the RC means, so the RC will be cancelled. So we get the I of t is equal to I of t is equal to V by R into e to the power minus 1. E to the power minus 1 value is 0.362 times of V by R. So it will be reach the final value from the initial value. Final value from the initial value is 36.2% of V by R. So we are marking the final value means, so that will be reach the final value from the initial value is 36.2% of V by R. V by R. Okay. Next we are going to find the voltage across of resistor and voltage across of capacitor. Voltage across of resistor, that is nothing but of VR. So VR is equal to, we know the I of t into R. So I of t already we have find the transient current from equation number 3. So V by R into e to the power 1 by RC into T into R. The R will be cancelled. So voltage across the resistor is equal to V into e to the power 1 by RC into T. So this is the voltage across of resistor. Similarly, we are finding into the voltage across of capacitor. Voltage across of capacitor VC. So as per the KVL, we know the V is equal to applied voltage is equal to voltage drop across the resistor plus voltage drop across the capacitor. We need the voltage across of capacitor VC is equal to V minus VR. So V into, so VR value already we have find the voltage across of resistor. VR is nothing but of V into e to the power 1 by RC into T. So in these two terms V is common, we can take down the outside means V into 1 minus e to the power 1 by RC into T. So this is the voltage across of capacitor. Voltage across of capacitor. Now we can draw the response curve for voltage across resistor and voltage across capacitor means, voltage across resistor means, so first we are going to substitute the t is equal to 0 means, so the e to the power 0 value will be 1, we get the value is V. So second extent is we are applying into the infinity means, so e to the power minus infinity 0 into anything 0. So we get the response like this. So this is for voltage across of resistor response. Similarly, we are draw the response of voltage across of capacitor means, so first we are substituting into the 0 means e to the power 0 is 1, 1 minus 1 is 0, 0 into anything will be 0. So one more extent we are substituting into the infinity, t is equal to infinity means e to the power minus infinity will be 0. So only we get the V value alone. So this is for voltage across of capacitor. Okay. So we can draw the two response, one for transient current response and another one response is voltage across of capacitor and voltage across of resistor response. Okay. So next we are going to discuss about the RC transient decaying circuit. Next we are going to discuss about the RC transient decaying circuit. In first case, we are applying into the voltage through the switch R and C. So both the elements are connected into series. So initially we have a voltage. Initially the capacitor will be charged into up to V. Okay. Now we are removing the switch S into connected into the another position, that is the position number 2. So I am changing into the position number A to position number B. Now the circuit is redrawn by R and C. Only we have a two elements. The current flows through this circuit is I of t. So why the RC and decaying circuit is nothing but of source free circuit. Source free circuit. Why it is called the source free circuit means we are removing into the source, we are connecting only for the capacitor and resistor alone. Now we are applying into the KVL means applying KVL means, so I of t into R plus 1 by C integral of I of t into dt. So now we have a charge on this capacitor, we have a charge on this capacitor, that is nothing but of V of 0 is equal to 0. So I of t into R plus 1 by C integral of I of t into dt. So the initial charge that will be converted into voltage means that will be V by R times it will be charged. So V by R is equal to 0. So I of t into R plus 1 by C integral of I of t into dt is equal to minus V by R. So you can take as it is, this is for equation number 1. Now we are applying into the Laplace transform on equation number 1. So I of t is converted into I of s into R plus integral is there. So 1 by sc into I of s. So minus v by s into R. So we need I of s. We can take down the outside means I of s into R plus 1 by sc is equal to minus v divided by s into R. So I of s is equal to minus v divided by s into R plus 1 by sc. Now we are taking the LCM for this term means I of s is equal to minus v by R into 1 divided by s into RC plus s into RC plus 1 divided by RC, sorry, SC the S s will be cancelled. So, minus v divided by c into r into c plus sorry s plus 1 by RC, CC will be cancelled. So, I of S is equal to minus V divided by S plus 1 by RC. So, our ultimate aim is we are going to find the I of t. So, I of t we are taking into the inverse Laplace transform, taking inverse Laplace transform means we get the I of t is equal to minus V by R into minus V into e to the power minus 1 by RC into t. So, we can draw the response graph means t, I of t means. So, we have a negative value. So, the 0 means t will be 0 means I of 0 means we get the V, I of infinity means we get the value is 0. So, this is the transient response, transient RC response of decaying circuit. Okay. So, now we can solve the one problem in RC transient circuit. So, we are applying the voltage is 20 volt connected through the RL element through switch S. So, the R value is I am going to take the 10 ohm and C value is I am going to take the 0.1 farad. These two elements are connected into series. Okay. Now, I am going to close the switch S at t is equal to 0 seconds. T is equal to 0 seconds. Now, the current will be flows through the circuit is I of t. So, already we have discussed into the derivation, same procedure only we are going to follow the solving problem. So, first applying into the KVL, applying KVL means, so 10 into I of t, R into I of t plus 1 divided by C, C value is 0.1, integral of I of t into dt is equal to applied voltage. So, the applied voltage is given into 20 volt. You can take this is for equation number 1. Now, we are applying Laplace transform means applying Laplace transform on equation number 1. Equation number 1 means, so 10 into I of s plus 1 divided by, we have a integral part. So, s into 0.1 into I of s is equal to, so 20 is constant, we can take the Laplace transform means 20 divided by s. So, in these two terms we have I of s is constant, we can take down the outside means I of s into 10 plus 1 divided by 0.1 s is equal to 20 divided by s. So, I of s is equal to 20 divided by s into 10 plus 1 by 0.1 value is 10 by s. So, we can take the LCM for this term means, so 20 divided by s into 10 s plus 10 divided by s. Now, s will be cancelled. So, finally, I of s is equal to 20 divided by, so we can take down the 10 is outside means 10 into s plus 10 divided by 10 is 1. Okay. Our ultimate aim is we are going to find the I of t, so that we are going to take the inverse Laplace transform, taking inverse Laplace transform means I of s will be converted into I of t is equal to 2 divided by s plus 1. So Laplace inverse of I of s is equal to Laplace inverse of 2 divided by s plus 1. So I of s is converted into I of t, 2 is constant, 1 divided by s plus 1 is converted into e to the power minus t. So this is the current flowing through this circuit. So the unit of current is ampere. Next we are finding the voltage across of resistor. Voltage across of resistor. Voltage across of resistor. So we know the voltage across of resistor is denoted by VR. So VR is equal to I of t into R. So already we have find the I of t. So I of t is 2 into e to the power minus t into R value. R is 10. We get the 20 into e to the power minus t. So this is the voltage across of resistor. Next we are finding into the voltage across of capacitor, that will be denoted into V suffix C. So we know the applied voltage V is equal to VR plus Vc as per KVL. Our ultimate aim is we are going to find the voltage across of capacitor. We are rearranging this equation, means Vc is equal to V minus VR. So Vc is equal to V minus VR value is. So in problem they are giving into the applied voltage is 20 minus voltage across of resistor is 20 into e to the power minus t. So Vc is equal to, we have a 20 is common, we can take down outside, means 1 minus e to the power minus t. This is the voltage across of capacitor. So from this we have concluded into, first we have derived the transient analysis for RC circuit for forced nature. After that we are derived into the transient analysis of transient response of the source free response. So finally we have solved into the one problem based on derivation. Thank you.